Hello and welcome to Lesson 3.2, Functions. Our objective for this lesson is that I can determine whether relations are functions, and I can evaluate functions in function notation for given values. Now, a function is a relationship in which each element of the domain is paired with exactly one element of the range. To say it another way, one input has exactly one output. Okay, a function, each input has exactly one output. Function notation is a way of writing an equation, and what we're doing is we're essentially replacing y with f of x. And the way you say that is f of x. So the function of x, or it could be g of x, h of x, whatever it may be, f of x is equal to something. Now, we'll talk about that more when we get there. The vertical line test. This is a test that we can use with a graph where we use a vertical line through the graph and it should intersect with no more than one time. So it'll intersect with the graph no more than one time as it passes through your grid. So let's take a look at example 1, identifying functions. So we have our mapping diagrams that we worked with yesterday, and we see in this case, we're focusing on this section right here, okay? And we see we have domain values of -4, -2, 2, and 5. And each one of those has only one output, only one corresponding range value that goes with it. So this is a function. Each input has one output. Even though -2 and 2 are going to the same place, they are only going to one place. There is only one outcome. -2 is only going to 3. 2 is only going to 3. So a way we could think of this, if you are traveling around town and you are going to the high school, for example, you could leave from Clinton Rosette at 2 and get to the high school. That would be a pathway. You could leave from Huntley Middle School and go to the high school, and that would be another pathway. You're going from one place to another. So it doesn't matter that both are meeting up at the high school. There is only one pathway that we're taking from that building to the high school. Let's look at letter B. Now, we have 4 inputs, and again, we are looking right here. And what we're specifically looking for is, do I have any values that are going to more than one place? And I do. I have a 3. It is going to 5, and it's going to 0. So this is not a function. Okay, and y, 3, has multiple outputs. So the way we could describe this, in the previous one, we had 2 different starting locations that were meeting at DeKalb High School. In this one, we're starting off at DeKalb High School, and one day we're saying we're going to the middle school, and we go to Clinton Rosette. And then the other day we're saying we're going to the middle school, and we end up at Huntley. We didn't necessarily say which place we wanted to go. We're going to 2 different pathways. So if we just said we're going to the middle school and you ended up in 2 different areas, that's a broken function. You are not succeeding at what you are trying to do. So you have 2 different destinations from that singular starting point. And if we think about this in terms of working and in terms of money, if I work 3 hours, I want to be paid 3 hours of pay. But if I work 3 hours and I get paid $50 one time and I get paid $20 another time for working the same 3 hours, that's a problem because I'm not getting paid the same amount. My function, my rule is broken. So that is what we're looking for. We want to make sure that each input only goes to one output. So letter C, we have domain and range. So we're going to take a look and we're going to focus on the domain up here. And we look to see, do I have any repeated values? And I do. I have 2 is being repeated twice. and it's going to two different locations. One is going to 3 and one is going to -3. So we have, it is not a function, and that is because we have a repeat domain and it is got with different ranges. So if we had two, and let's say this one was also a -3, well, then it's going to the same place. Even though we have two instances of that domain, it's going to the same range. But because one is going to +3 and one is going to -3, now it's taking us to different places. All right, we have two U-try problems for you here. I want you to try them on your own, and then we'll go over them as a group. So our first one is using a mapping diagram, and as I look at this, each one of my inputs is only taking one pathway away from it. So this is a function. Each domain only has one range. Each domain value only goes to one place. Letter E, we have domain and range again. We're in a table, so we're looking at our table up top. And I'm looking at it and I do not see any repeated values, so this is a function. Each same reasoning. Each domain has one output. So each input only has one output. So let's go to the next page. We're given some data about a track meet. And we have 5 schools competing in this meet in the long jump competition. The distances of the players with the best jump on each team are as follows. Team 1 is 20.6 feet. Team 2 is 21.5 feet. Team 3 is 20.9 feet. Team 4 is 19.4 feet. And Team 5 is 20.2 feet. Not entirely sure who is measuring this in imperial units instead of the standard metric units that we use when we measure track stuff. But here we go. We're going to fill in the table. Our top line is going to be our team numbers. So we have 1, 2, 3, 4, and 5. Our bottom line is our distances. So 20.6, we have 21.5, we have 20.9, we have 19.4, and we have 20.2. So now we're going to determine the domain and range. Our domain is going to be our x values. So that's going to be 1, 2, 3, 4, 5. We write them, we just separate them by a comma. Our range is our y values, it's our distances. 20.6, 21.5, 20.9, 19.4, and 20.2. Again, we separate them just by a comma. So determine whether it's a function and explain. This is a function. Each input has one output. So a team isn't entering 2 scores into this. Each input only has one output. Now, letter B, we have Bailey, and Bailey is recording the height of her friends. The heights in inches are as follows. Hunter is 62, Ling is 66, Ella is 65, Omar is 66, and Alma is 67. So our name is our first line, and our height in inches is our second line. And I always include my units whenever I'm putting it in a graph. If I put it in the header, or in this case in the left margin, I know that everything in that column is going to be, or in that row is going to be a that unit. And this is specific because when we are looking at, like for the last problem, right? The difference between 20 feet and 20 meters is drastic. 20 meters would be 3 times as far as what you would see in if it's being measured in feet. So in this case, inches, well, if we're measuring in like centimeters, that's drastically different than inches. So you need to specify what units you are doing or what units you are using in order to be appropriate with your data. So we're going to put in the names. We have Hunter. We have Ling. We have Ella or Ela. We have Omar. And we have Alma. All right, and the heights of these individuals, Hunter is 62, Ling is 66, Ela is 65, Omar is 66, and Alma is 67. So we list out our domain, and those are going to be our names. So Hunter, Ling, Ela, Omar, and Alma. And our range values, we have 62, 66, 65, 66 is repeated, we don't need to write it again, and 67. So is this relationship a function? Yes, and it's the same reasoning as above. Each input has one output. It'd be a little strange if Hunter had 2 different heights associated with him being measured at the same time. That'd be kind of weird. Somebody's doing something wrong, or something is being changed about the scenario. All right, the next page at the top is a U-Try problem. We have Madison taking 5 quizzes this semester. Her scores on the quizzes are as follows. Quiz 1 is 86, Quiz 2 is 92, Quiz 3 is 78, and Quiz 4 is 86, and Quiz 5 is 84. And we want you to go ahead and do the same thing. Make a table, find domain, range, and identify if it's a function. Do your work, and then come back and check it with me. So we have the quiz number is going to be our first line, and our score is our second line. So our first quiz was an 86, second quiz was a 92, third quiz was a 78, fourth quiz was an 86, and fifth quiz was an 84. So now we can list out our domain. So it's 1, 2, 3, 4, 5. And our range, 86, 92, 78. 86 is repeated, so we don't have to rewrite it, and 84. Is this a function? Yes. And the reason why? Each input has one output. Now, I'm going to pose a thinking question to you. If I were to want this to not be a function, how could I change this scenario? What could I do to this setup of the question to change and make this not a function? All right, now that you've thought about it for a moment, what if I said, you know, that 78 score on that third quiz, she wasn't a fan of that. So maybe she takes the third quiz over as a retake, and now she gets, let's say she got a 90 on it. Is this now a function? No, it's not, because she did a retake. She has 2 different scores for 90, or for question number or quiz number 3. She has 2 different scores. And so that would make this not a function. So if we did that little addition there, then it would be not a function. Okay. All right. So now we're going to go and we're going to use the vertical line test. And what is this crazy test, Mr. Boland? You draw a line that is vertical, and you move it across your graph. And if it touches more than one point on your graph, it is not a function. So is this one a function as I'm moving this line back and forth? It is only crossing my graph at one point, so this is a function. Now, if I bring my line over to my next one, letter B, my line is hitting in two spots on my graph, there and there, so this is not a function. Okay. Now, if I go over to letter C and I move my vertical line across, again, I am only hitting one point on the line, so this is a function. Now, if I look at letter D, we have 2 points being crossed at a lot of times. So like if we do a point there and a point there, it's crossing there. So that is not a function. All right, you guys try letters E, F, G, and H on your own, and then I will go over them in a moment. All right, letter E, as I put my line on here, I see that this is not a function because our line is touching more than one point. Now, what about letter F? What's going on here? Well, if I put my vertical line on this, hey, look, my line almost disappears. And that's because this is a vertical line. This is an example. This line is x is equal to 4, meaning that x will always be 4. So this is not a function. And the reason why? Because the vertical line test, that vertical line will cross every point on that graph. Now, letter G, we can look at this one, and it's either a sine or a cosine graph. I don't remember which one. But as we are moving our vertical line across it, there's different rates and different slopes happening, but this is a function because there is not a time when we have 2 points being connected by that vertical line. All right, and if we go to our last one, letter H, we have this really elongated U shape. And as I'm going across, I am not seeing any multiple points, so this is a function. All right, as we go to the next page, we are looking at equations as functions. Now, an equation can be a function in a couple different ways. This first one here, we have an equation written in standard form. It's a linear equation, and we can solve it and put it in slope-intercept form. If we subtract 6x from both sides, we get 2y equals negative 6x plus 14. Divide by 2, we get y is equal to negative 3x plus 7. This is slope-intercept form. Which you should have seen in 7th grade a little bit. So we have slope-intercept form, and the graph that we have here is a corresponding graph for this. And again, if we look at it, we have a vertical line, so this is a function. So if it can be written in y equals mx plus b form, it is a function. And what about letter B? Letter B, we have just y equals 5. Well, if y equals 5, that could be in slope-intercept form. It could be y equals 0x plus 5. It could be in standard form, 0x plus y equals 5. Either way, it's a horizontal line, and when I do my vertical line test, it is only crossing that vertical line, or that horizontal line, at one point, the point 5. So this is a function. Now, we have 6 statements here for you to read on your own, and then you are going to determine, are they going to be resulting in a function? So the first one we have is the relation passes the vertical line test. Yes, that will be a function. An element of the domain is paired with only 2 elements of the range. That is not a function because you can only be paired with 1 element of the range. The domain represents each student in a class, while the range represents the age of the students. That is a function because the students are not being repeated. Each student has one distinct age. The relation is in the form y equals mx plus b. That is slope-intercept form. Yes, that is a function. A vertical line passes through more than one point on the graph. That is a no. It is not a function because that would be 2 different outputs for the same input. And the relation is of the form y equals x squared plus b. Well, x squared plus b is a graph that's shaped like that. It's U-shaped, so that is a function. Now we're going to go on to our next page, which is evaluating functions. So when I evaluate a function in function notation, I am taking this value and I am substituting it for x in the equation. Okay, so we're going to do this. We're going to do f of 2 is equal to negative 6 times, we're going to substitute in 2, and we're squaring it, plus 18 times 2 plus 36. So we do our multiplication first. F of 2 is equal to, we have negative 6, 2 squared is 4, plus 18 times 2 plus 36. Our next step, we do our multiplication. F of 2 is equal to, negative 6 times 4 is negative 24, 18 times 2 is 36, and we have another plus 36 at the end there. My last step is going to be to combine like terms. So f of 2 is going to be equal to 48. Now, letter B, we have f of 4. So we're going to substitute that in. So we're going to do, and I'm going to skip the f of 4 part. So we got negative 6 times 4 squared plus 18 times 4 plus 36. First step I do is going to be deal with the exponent. 4 squared is 16 plus 18 times 4 plus 36. Now I do my multiplication. Negative 6 times 16 is negative 96. 18 times 4 is 72 plus 36. My final step is to add them all together, and when I do, I get 12. Letter C, we have f of 5. So we're going to substitute in 5 in my equation. So we have negative 6 times 5 squared plus 18 times 5 plus 36. So now I go through and I do the math. Negative 6 times 5 squared is 25 plus 18 times 5 plus 36. My next step is to do my multiplication. Negative 6 times 25 is negative 150. 18 times 5 is 90. And we have plus 36. Last step, do my addition, and I get negative 24. Now, at the top of the next page are 3 you-try problems. I want you to do those on your own now and check your work against mine. So we have function of 2. So we have we're going to do 2 times the quantity, 2 squared, minus 8 times 2 minus 10. 2 squared is 4, minus 8 times 2 minus 10. So now I have 8 minus 16 minus 10. When I do that subtraction, I get negative 18. Letter E, we have f of 5. If we go ahead and do this, we have 2 times 5 squared minus 8 times 5 minus 10. You'll notice I'm putting all of my substitutions in parentheses so that I know what I'm supposed to be working with. So 5 squared is 25. Now we do our multiplication. We get 50 minus 40 minus 10. 50 minus 40 minus 10 is 0. And lastly, we have letter F. We have 2 times 8 squared minus 8 times 8 minus 10. First step is to do the squaring. 8 squared is 64. We've got 8 times 8, and we've got minus 10. All right, now 2 times 64 is 128, minus 64 minus 10. When we do that subtraction, we get a total of 54. All right, we're going to move on to example 6 now. Example 6 is interpret function values. So we are going to start with this scenario. Mason works at a movie theater after school. The function f of x is equal to 9.25x represents the amount of money he makes before taxes for each hour that he works. Evaluate and interpret the function for each value given below. So as we look at our first value, we have f of 8. So we're going to substitute that into our equation. F of 8 is equal to 9.25 times 8. And when we do that multiplication, we are going to get that f of 8 is equal to $74, because we're talking about the amount that he is getting paid from his day of work. Now, f of 14, we are going to do the same thing. F of 14 is equal to 9.25 times 14. And when we find that, f of 14 is going to be equal to $129.50. If you just wrote it as $129.5, I would accept that, but money, we would add the 50. And that is a key point of distinction here. These are both talking about money, and the third one is also talking about money. So we do need to include our units, and we have it because f of x, the function, represents the amount of money he makes. All right, letter C. We do f of 20 is equal to 9.25 times 20. So if he worked halfway to full-time employee status, he is going to make a grand total of $185 over those 20 hours of work. Now, the next problem on the next at the bottom of this page is a you try problem. So I want you to go ahead and try that and then check your work against mine. So f of 3.25 is going to be equal to 600 times 3.25. And when we do that multiplication, we get f of 3.25. So 3.25 hours of filling is going to give us 1,950 gallons of water. Letter E, we take that same expression and we are going to put in 600 times 11.5. So almost half a day of filling this pool. And so we have f of 11.5 is going to be equal to, when we multiply that out, we get 6,900 gallons. And lastly, we have f of 6 and that's going to be equal to 600 times 6. So, a quarter of a day of filling. F of 6 is going to be equal to 3,600 gallons. All right. Those are our notes for Module 3.2. If you have any questions, please bring them to class tomorrow. Have a great day.